Quantum Cosmology, a geometric kinematic framework of brain-string integration in the multidimensional bulk. Abstract. The present treatise introduces the formalism of cyclic quantum cosmology, a cutting-edge model that resolves the singularities of general relativity and redefines the nature of space-time through the structural integration of D-BRANE theory and excited strings. Within the CQC framework, the observable universe is described as a semi-rigid $3 brane, embedded in a higher dimensional bulk. The Big Bang is stripped of its nature as a quantum singularity and reinterpreted as a highly inelastic kinematic collision between adjacent branes. This impact generates a plasma of fundamental strings that organize into three distinct topological classes: space strings, which compose the geometric fabric of the vacuum; matter strings, confined particles; gravity strings, closed loops free to move in the bulk. Through this tessellation of the vacuum, the treatise analytically resolves the enigma of hypermature primordial galaxies observed by the James Webb Space Telescope and redefines black hole thermodynamics as engines of geometric phase transition from matter to space. Chapter 1: D-BRANE Impact Dynamics and Cyclic Cosmology. 1.1 Topology of the $3 brane in the multidimensional bulk. In cyclic quantum cosmology, four-dimensional macroscopic spacetime is not an isolated geometric entity, but rather a differentiable submanifold, specifically a semi-rigid $3 brane defined as $mathcal $4, embedded in a higher dimensional projective space endowed with its own metric, termed the bulk. The global metric of this multidimensional structure is modeled by extending Randall-Sundrum-type solutions with an anti-de Sitter background, ds², where $$ is the extra-dimensional coordinate orthogonal to the surface of our brane. $$ represents the intrinsic curvature factor of the bulk. $$ represents the induced metric tensor on the brane, which determines the physical geometry of local spacetime in which we operate. The cosmic brane possesses an intrinsic surface tension $mathcal _polar and is subject to sliding and oscillation dynamics along the coordinate $. Its motion within the bulk is described by the relativistic Dirac-Bornenfeld area action. Mathcal. 1.2 Quantum mechanics of brane impact. The cosmological event traditionally classified as the Big Bang is formalized here as the limiting kinematic instant of an inelastic collision between our brane and an adjacent parallel brane in the bulk. This periodic impact defines the phase transition between two consecutive cosmological cycles, termed eons. Unlike conventional ekpyrotic models where the collision is entirely elastic, CQC establishes that the collision is a highly dissipative process. It converts the kinetic energy of motion along the extra-dimensional axis $$ into microscopic vibrational degrees of freedom on the brane. Primordial field compression during the approach of the two branes, the intermediate quantitative space shrinks to zero. Gauge fields undergo extreme confinement, increasing energy density without ever reaching a mathematical singularity of infinite density, since the impact distance is bounded below by the fundamental string length $L_. Inelastic string nucleation at the instant of contact, the kinetic impact energy excites the vacuum of the bulk, triggering a process of spontaneous nucleation of fundamental strings and superstrings. These strings remain predominantly anchored to the surface of the brane. The aeon spectrum, each brane collision possesses its own angle of incidence and relative collision velocity within the bulk. These physical parameters define the fundamental frequency spectrum of the nucleated strings for that specific aeon, establishing the effective values of Planck's constant $bar$ and the speed of light $$ for the entire duration of the cosmic cycle. 1.3 The residual strain tensor. The impact transition imprints a quantifiable geometric excitation onto our brane $mathcal $4, expressed through a residual strain tensor denoted as $. This tensor describes the accumulation of elastic energy on the surface of the brane. During the early stages of the aeon, the brane undergoes a geometric relaxation process governed by the equation nabla to the power of mu times s, where $for $ is the scalar relaxation field. $at $1 represents the elastic viscosity constant of the brane. The dissipation of the residual strain tensor drives the primordial accelerated expansion, the mathematical equivalent of standard cosmic inflation. Gravity is therefore not merely a passive curvature induced by mass, but rather the measure of elastic tension generated when the brane slides along the network of excited strings produced by the original impact.